Hello and welcome. I am Gauhar Raza and you are watching Eureka. Chennai happened. The crisis was deep and very fast. Everybody got unsettled. The entire country looked at Chennai and thought that we have to deal with this crisis. In this hour of crisis, Council of Scientific and Industrial Research also moved in. Council of Scientific and Industrial Research, which has been working on water security of the country for a very, very long time. Welcome, Dr. Professor Mishra to Rajya Sabha channel, and we are very thankful that you gave time to us. Let me begin by asking you a question that when Chennai happened, as a scientist, you could have been in your laboratory and not bothered about the outside world. That is what expected out of scientists. How did you feel at that time and why did you move so fast to reach the population of Chennai?
Well, first of all, I come from an institute where we do research and develop technologies that have direct application to rural mass. And when we watch television and see these heart-rendering scenes, particularly in those flood-ravaged areas, we immediately realized that we perhaps could do something and be a part of that relief effort. And our leadership also took a position in that. And at Bhubaneswar, we have certain water-related gadgets, so to speak, that can be disseminated in that particular area. So we immediately mobilized our resources along with other team members and provided the much needed support there.
So the first thing was that CSIR moved in with the CFTRI, which is responsible for food technology in the country. That was immediate relief that was required. But later on, when did you realize, when the team was formed across laboratories, that water is going to be a major problem in the city?
Well, it's a rain effect. So we realized that this water is not going to go, it's going to stay. We had some time and we have filtration units. I mean, in fact, CSIR has many filtration units. It's coming from all the way. This is Chennai. We can go to Jammu. There also
Jammu and
this side Bhavnagar, east side Bhubaneswar, and then in between you have Niri, also NCL. All these laboratories in some way or other, they have worked on water.
About 10 laboratories got together immediately and then moved in very fast.
Yes. But like you said, proximity sort of decided who would reach there first.
But your own two laboratories in Chennai were underwater. So how did you cope up with that kind of situation?
Well, first of all, our laboratory CLRI is there. They realized what would be the problem with respect to their areas of expertise, and they were all inundated. Laboratory was closed, our ERP system was not working, computers were all down. It was very difficult to communicate, and that time, thanks to the media, we were able to appreciate the enormity of that
and assess the situation.
Problem and assess the situation. And therefore, immediately we coordinated among our laboratories. And these things are such, some of these equipments like mobile vehicle, mobile systems, they can perhaps approach faster. At the same time, the kind of things that I developed there, our laboratory has expertise in that, that would take some time. So we perhaps reached after 5 to 6 days. This water is not, you got to understand why water is not shifting so fast. Unlike Bhubaneswar, or that part of the country where we have laterite rock bodies, it's easy for water to drain out. But in this part of the country, Chennai, it's all clay type of material. and a lot of drilling goes on and you pump water from down below.
Right.
So the water level has gone down. So up there it may appear that it's all dried and you allowed construction to take place. And when water comes, unlike
it was unplanned construction that was responsible
unplanned
for
construction.
this. And it is going to be waterlogged area for a very long time.
Because it's clay, it's not going to seep through. If it were rocky area, water
It would have flown.
It would have flown, very simple. And on that, if when a stream comes and it has its own bay and you have construction there, then the whole thing gets
Could you
flooded.
tell us that what kind of filters were there? Terrafill to water, Neerzar and others. Why were these important?
These
What
are,
is technologically important as far as
well, you may ask, in fact, we are in Chennai, lot of water there because it's on near the ocean, okay? But that water is salty. So we have technologies to treat that kind of water, which would be costly. But the water, surface water that has accumulated over certain pockets in ponds, in other places, they can be treated separately. So we have a range of technologies from using RO type of technologies to simple filtration technologies which takes care of turbidity, bacteria and whatnot, gives you a simple water.
the population that got affected? It is about 50 lakh population.
Yes.
And almost everybody got affected.
Yes.
But about 40 lakh people were affected very intensely.
Yes.
Now the enormity of problem is such that it must have been very difficult to deal with.
Yes.
What kind of filters can deal with such problem? One is that you require in large number. Two, the capacity of the filters should be very, very large. Do we have in CSIR capacity to deal with this situation?
I think you said it correctly. It's number you cannot meet 50 lakhs or the number that you are alluding to, but capacity, if we can think of higher capacity devices, say for example, we have a 30 liter capacity TerraFill water filter that we give.
30 liter per day or per hour?
But you can do 3 times a day, which takes care of a family of 4. Okay, but at the same time, you can imagine.
How many filters of such kind were sent by your laboratory?
We have about 1,000 we are planning. But this is for really people, those who cannot afford anything, cannot even speak for relief. I mean, we are talking about poorest of the poor. So that's where we target our things. RO, somebody can pay a little more and get it, and so scale and level.
Scale was very important. I have to take a break. Don't go anywhere. We'll come back soon. Welcome back. Professor Mishra, we were discussing Chennai. This can happen in any part of the country. This is not the first disaster that we have faced. It's not going to be probably the last one. With the technology like TerraFill we were talking about, we have made probably the cheapest of the filters, water filters, and with local material. Do you think that such filters can be made without getting into deep science and technology?
Yes, that's a very good question. First of all, before I discuss this, I must give credit to the inventor. He's Mr. Surendra Khuntia, who was just superannuated, and we couldn't retain him. And he's there in Bhubaneswar helping us in every step. Now, the way TerraFill filter is made, it's quite simple. You find local clay, add sawdust to it, and you have a baking oven, you bake it. So these dust particles in that temperature, they burn off, leaving a pore behind in the clay matrix. So the water goes through and gets separated. First of all, the suspended particles, they are sort of stopped, filtered. And then bacteria, we make the pore size in such a way that bacteria also stop. So
can you control the pore size without getting into deeper technology and science?
Well, this is how we do. The sawdust, you control the size of the sawdust.
Right.
But more important, you realize it's not a problem in Chennai, But in other parts of the country where iron contamination is very high, it takes care of about 92 to 95% of iron. It gets precipitated. If you open the TerraFill water filter after a month or two, you'll realize red material is accumulated.
Yeah.
Yeah, that you have to wash it up, clean it. And we have some community sized TerraFill water filter we have installed in different parts of the country. For a small village with 250 people, they are depending on that. They are getting a very clean and pure water.
IMMT has also made filters ranging from very small filters for household capacity, which is 1 or 2 liters an hour, to 50,000 liters a day.
Yeah, yeah.
Now, these are very large filters. Where have you installed them?
Say, for example, in
But before that, has the technology been commercialized?
Well, this technology is commercialized in the sense that we think of it as under MSME program. We give it very low cost technology,
You don't earn much.
almost free. In small ghettos, people where they live or something like that, if they can afford, we can give them 300, 400 rupees TerraFill water filter, 30 liters capacity. But supposing you go to a temple where thousands of people, they come there and eat there,
Right.
to supply them continuous clean water in a remote part of the country, we have installed, say in Koraput district, very large TerraFill water filter system, continuous flow under gravity, and it
You don't require any energy source, electricity,
that's the biggest
solar panel or something. Nothing is
of that, sir.
required.
That's the
We
biggest
have developed
advantage.
this technology.
Yes.
Similarly, NEERI has developed
Yes.
technologies
Yeah,
which
yeah.
are also directed towards a particular kind of filtration,
Yes.
like fluoride,
Fluoride. Yeah.
removal
Yes,
or
yes.
arsenic removal.
Right, right.
Arsenic has been a problem throughout the country.
Yes,
That
yes,
contamination
yes.
causes a lot of diseases.
Yeah, yeah.
So, NEERI has developed that technology.
Right.
Now, can we not import everything and not spend so much of time on building such institutions?
No. It will be it won't be a cost-effective solution. And fluoride contamination, let's say some part in my state, we have fluoride contamination problem, and we are trying to address that with our scheme of things. Okay. Similarly, arsenic, what you are saying, it's again in eastern India along the Gangetic
And southern part of
belt,
India, Nalgonda
southern part
area.
of-
That
Yes, we have arsenic
17
problem.
states are intensely affected across the country with arsenic contamination.
Right. There is a startup through IIT Madras. They have developed a technology to take care of arsenic, and you have to fix arsenic somehow that at a later stage it will not leach out, because arsenic is very risky.
What is water security for the country?
Well, water security is water itself contains those 3 words, WAR. There will be war. So if you don't have water, our groundwater level is slowly falling. And this has been published in Science magazine and everywhere.
Absolutely. Average water table is going down.
Yeah, so we have to by some means conserve water. And conserve in a sense that we have industrial water, we have domestic water, we have sewage water, and then there are technologies that we are trying to convince people that you conserve water through rainwater harvesting, through other methods. We have to do that. We have to look at it in a holistic way. Today, NEERI and our laboratory in the state of Bhubaneswar, we are taking all this surface water, including sewage water, treating them in what are called constructed wetland, and we are cleaning the water, then discharging. In advanced countries, I saw in...
And again, this technology doesn't consume energy.
This doesn't consume, the constructed wetland technology doesn't consume energy. And but you can go a step further. The same water can be recycled and put it in a manner so that it becomes potable water.
You are part of the task force within the Council of Scientific and Industrial Research, where you look at the water security. Now, what is the future? How are we looking at the future as far as water? See, there are rivers to be cleaned. As you said, the problem is that table is going down, contamination is happening. Then we are mining a large area within the country, and that is creating problem at both levels. The total amount of water is getting reduced, which is available to us, and the water that is available is getting contaminated.
Right.
So how do you look at the future? Is CSIR going to focus in this area?
You see, we have decided to pursue a very big program. At least in engineering cluster in some of the laboratories, we have put water and wastewater as a major thrust for coming 5 years. And in that scenario, it's not the availability of water which is important, but it's the contamination of water that we are putting our emphasis on. And in that Ganga and other things that you are talking about, that's there. So we want to look at the problem in different stages based on our expertise, like ourselves.
And you are confident that we have expertise, will be able to take care of the country's needs?
I believe only science and technology will provide the solution, nothing else.
It's just wonderful. That gives a lot of confidence to us. I have to take a break. Don't go anywhere. The discussion will continue. Welcome back to Eureka. Professor Mishra, we were discussing that water is getting contaminated. Pollution is a big problem. But it's not only water pollution that is a big problem. Air pollution, global warming, climate change, all these things are related to each other. Your area of work personally as a scientist and technologist has been to clean the air, and especially related to steel industry. Would you like to talk about it?
Yeah. See, I come from a laboratory which looks at resource utilization, resource conservation, and at the heart of it is sustainability. So in our country, we have major resources like iron ore, coal, bauxite, and many other industrial minerals like graphite, clay minerals, and stuff like that. Now, what is happening today, the way we are consuming and we are exporting and the way we are planning. I'll give you one example for iron, for example. We are per capita wise now using 64 kgs per person per year.
Right.
Okay. The world average is about 230 kgs, for example. If you aspire to go from 60 to 230, then your iron ore requirement will be huge. Today it is 170 million ton. It's going to cross 500 million tons. At that rate, if you are going to mine and extract and make steel, then very soon you have nothing left for next generation. Now, when we talk about this, environment is coming into everywhere. It is coming into picture. We monitor P10, we monitor P2.5, and all these things. But I believe the only solution that you can provide to all these things through technologies.
Right.
We have to use advanced technologies for power, for
We have to
steel.
use, or we have to also develop?
We have to develop and use also. Some technologies are available.
Right.
So, in my opinion, we should immediately adopt advanced technologies. Like, for example, if you take power plant with supercritical, supercritical boilers and stuff like that, you can take 100,000 cars off the road, equivalent to, that's carbon dioxide abatement.
Emission, yeah.
Yeah, and our CSIR as a whole, we are looking at those who are involved in environment. How can we develop materials? I'm a materials person, which will absorb carbon dioxide.
What is this technology that you have developed as far as iron is concerned?
Yeah.
Iron making produces a lot of CO2,
Okay.
carbon dioxide.
Yeah.
And you claim that the method that you have developed would restrict emission of carbon dioxide. There's only one other institute in the world, MIT, which is claiming that.
Yeah. That's
so
correct.
what is this?
That's correct. It's a very futuristic thing, and I'm thankful to Ministry of Steel. I have a team of scientists, those who are doing this work. Now, what we are thinking today, if you want to make 1 ton of steel, you are sending 1.6 tons of carbon dioxide. Now, this contributes to about 6.3% of carbon dioxide overall pollution, total carbon dioxide.
Which is very huge.
Which is huge. So then question comes to why we make steel in this way. So we thought about it, and thanks to some of my predecessors, Dr. Rajkishore Param Guru and current Dr. Bhagyadhar Bhoi, they all helped me to proceed with this plan. Today, we are able to use hydrogen gas instead of coal as a reductant in a plasma atmosphere. We have a innovation center for plasma technologies, and we are reducing iron ore in hydrogen, where interestingly the byproduct is water, steam, which is quite benign. So the work
which is not harmful to the environment.
So in Gujarat, we have demonstrated this at 1 kg scale, and we want to go for 5 ton scale in a pilot plant. So the hydrogen is going to come from hopefully Gujarat Fertilizer and Chemical Corporation. They have agreed to give us hydrogen, and I'll go through with a project proposal and request our minister.
It's a very different technology as compared to MOE?
A completely different technology. It's
because they are also claiming, but some people have questioned because you are shifting power consumption from the industry to some other area, because it is highly power intensive.
I understand that. The reason for that is at the present stage, maybe the hydrogen economy is not well established. But future is there. Hydrogen is the promise for the future.
You are very excited, and your team probably is very excited, and it has been recognized that it has a potential. But is industry also excited about it?
At the present stage, I have two Steel Authority India Limited and Rashtriya Ispat Nigam Limited. They are in Vizag. They are coming forward to partner with us to scale these technologies to industrial level. So
congratulations, that's a wonderful idea. What has been the moment of Eureka in your life?
Moment
of Eureka in your life. When did you say, yes, I have done it, yes, I have achieved it?
Yes, that all started, 2-3 things that all started. One is that I decided to go to US to acquire that knowledge which was lacking when I was working in industry. Second was that I decided to come back to IIT Kanpur and do whatever I had to do there. The most important thing is that I came back to CSIR.
You have shifted job from one place to another place, went abroad, you came back, I don't know why. A lot of pressure must have been there that you stay back in United States, and then come to CSIR, where technology is getting developed. So is it because you were a part of industry right in the beginning of your career that you wanted to come to CSIR?
Well, the reason that frankly when I came here...
Before that, why did you come back to India?
No. Well, there are different reasons. I always wanted to come back to India. That was there in my heart. And
to serve the country, to take care of your parents.
Yes, I wanted to do that, and that's expected of us. And I thought my role will be cut out here, India, not there. The kind of research I was doing. But that 10 years of experience, I picked all good things from there. And saw that I implement that in my teaching habit, teaching style, and I did that. Then I realized in Kanpur that I will not be able to expand the kind of work that
you wanted
I
to
am
do.
planning. Whereas in CSIR, big workforce, everything big. Here, which that opportunity one won't get outside. So
you have had experience of abroad, education in India, private industry, an academic institution, one of the best in the country, IIT Kanpur, and now in CSIR. Would you like to give a message to younger generation based on your experience?
Well, I would say, I mean, this is the startup era, okay? And we would see about 20% of our population, if you look at the demography, they are between 15 to 20 age group, okay? I did that. I convinced some of my students to go in that direction. I would say, don't depend on anybody to give you a job, create your own job, and make a, go in that startup line. And I have a very successful, venture there, and I can share my experience with younger people. Today in India, there are a lot of opportunities with respect to that. And slowly, you must be reading these days, many good students, they are opting for this. And we must facilitate.
Don't wait for anybody, create your own jobs. That is what is the message to younger generation. I am very thankful that you gave so much of time to us.
Thanks.
May I, on your behalf, promise our viewers that you will be happy to answer any questions if they want to ask?
Well, yeah, no
So do write to us if you have any question, query or comment. Our email address is eurekarstv@gmail.com. We'll be back with another scientist next week. Till then, goodbye.